Hello, this is Lucas Verkovich Layton, and this is my code review for the Capstone CS 499. I am reviewing the Travlr travel application that I built in CS 465 full stack development. It is a full stack web application built with the main stack, which is MongoDB, Express, Angular and Node.js. I am using this one project for all three categories: software design, algorithms, and databases. Let me show you how the project is organized. This folder, App Server, is the customer-facing website. It uses Express and Handlebars templates to show trip listings to visitors. This folder, App Admin, is the admin panel. It is an Angular app where administrators can add, edit, and delete trips. And this folder here, App API, is the backend API. It has the routes, the controllers that handle the logic, and the database models. Both the customer side and the admin panel talk to this API. Now let me walk you through the main code files for Category 1, Software Design and Engineering. This is app.js. It's the main file that starts the server. At the top, it loads all the libraries the app needs: Express for the web server, Path for file paths, Cookie parser, Morgan for logging, and Handlebars for rendering HTML pages. Here, it sets the handlebars as a template engine so the server can build HTML pages and send them to the browser. And here it is sets up course, so the Angular admin panel, which runs on a different port during development, can talk to this server. I will come back to this part in my code analysis because there is a security issue here. This is a routes file. It defines all the API endpoints. These two lines say If someone sends a GET request to trips, run the trip list function to return all trips. If someone sends a POST request to /trips, first check their login token with authenticate GWT, then run trips add trip to create a new trip. And these lines handle a specific trip. Get retrieves it, put updates it with authentication required, and delete removes it. Notice something about the delete line. I will point out the problem in my analysis. This is the trips controller. It contains the actual logic for each endpoint. The trip list function uses Mongoose to query the database. This line, model.find, with empty curly braces, means get every single trip with no filter. Then it returns them all as JSON. Now I will analyze this code using the code review checklist to find problems. Does the code completely and correctly implement the design? Does the code conform to any pertinent coding standards? The checklist asks, does the code follow coding standards? Here in app.js, in the line 38, the CORS setting uses a star, which means any website in the world can send requests to this server. This is a security problem. In a real application, you would only allow requests from your own front-end domain, not from everywhere. Here in the defensive programming part of the code review checklist, we have are imported data and input arguments tested for validity and completeness. The checklist is asking, are inputs tested for validity? Let me show you two problems with that. Look at line 57. This is the delete route. Compared to line 56 above it, the put route has authenticate JWT before the controller, which means you need to be logged in. But the delete route on line 57 does not have authenticate JWT. That means anyone without logging in can delete trips from the database. This is a serious security hole. Another problem here. In the trips add trip function, line 62 through 69, every field is taken directly from what the user sends in their request. There is no checking if the data is valid, no checking the length, no cleaning the input. Whatever the user sends goes straight into the database. Also, look at line 21. If the database returns nothing, the code tries to send back a variable called err. But err is never created anywhere in this function. This is a bug. It would crash the server with an error if this code path ever runs. The same bug exists on line 45, 78, and 119, as you can see here. Let's look at the documentation section. Is the code clearly and adequately documented with an easy to maintain commenting style? The checklist is asking about documentation. While the controller has some comments above each function saying what the endpoint does, there are no comments explaining the expected format of the data, what each field should contain, or what happens when something goes wrong. A new developer will have to figure this out by reading all the code. So based on these problems, here are my planned enhancements for software design and engineering. First, I will rebuild the Angular admin panel using React with TypeScript. This is like translating the front end into a different language with better type safety and a more modern structure. Right now, that panel manages its state with Angular signals in the trip listing component and with reactive forms in the add trip and edit trip components, and all of its data fetching lives in the trip data service. When I port it to React, each of those becomes a functional component. The trip list will hold its data with the use state and use effect hooks. The add and edit screens will use control form state, and the trip data service becomes a small data module built on Axios with interceptors that attach the auth token and handle errors in one place. So I am not just swapping frameworks. I am mapping each existing application state to its React equivalent. Second, I will fix the Express backend by adding proper error handling so the server never crashes from undefined variables, and by adding a central place where all errors are handled consistently. Third, I will add clear comments throughout all the code explaining what each part does. And fourth, I will add automated tests to make sure everything works correctly. This connects to the course outcome 4, which is about using modern tools and techniques because React and TypeScript are currently industry standards. It also connects to course outcome 1, which is about building collaborative environments, because well-documented code makes it easier for teams to work together. Now I will look at category 2, algorithms and data structures. Looking at the trip list function again, this line model.find with empty curly braces returns every trip in the database. There is no way to search trips by name, no way to sort them by price or date, and no way to filter them by destination, and also no pagination. If there were 1,000 trips, this will load all the 1,000 at once. On the front end side, this is the service that calls the API. The get trips function on line 23 just sends a get request and receives the entire list of trips. No search query, no sort parameter, no page number. It just gets everything. In the code review checklist, the structure part, the checklist asks if storage use is efficient. Loading an entire database collection into memory every time someone opens the page is not efficient. As the number of trips grow, this gets slower and uses more memory. Let's look at the loops and branches section. It also asks if loops and logic are complete. Right now there are no loops for searching or filtering at all. The data comes from the database and goes straight to the screen with zero processing. There is no sorting logic, no search logic, no filtering logic anywhere in the code. From a data structures perspective, the trips are just stored in a plain list. There are no optimized data structures for fast searching or ranking. If you wanted to find trips under a certain price, you would have to go through every single trip one by one. For my algorithms and data structures enhancements, I plan to add 4 features. First, sorting. Users will be able to sort trips by price, by how long the trip is, or by date. I will use a merge sort algorithm, which is efficient and handles large lists well. Second, search. Users will be able to type a name and find matching trips. If the search term matches the trip name, that result will rank higher than if it only matches the description. Third, pagination. Instead of loading every trip at once, the app will load one page at a time, like 10 trips per page. This is much faster for large amounts of data. Fourth, a recommendation feature. The app will use a hash map, which is a data structure that allows instant lookups to match user preferences to trip categories. Then it will use a priority queue to keep only the top 5 best matches. To be specific about the trade-offs, the merge sort I will use runs in O of n log n time, which stays fast even as the trip list grows. The hash map gives me O of 1 constant time lookups when matching a user's preferences, and the recommendation step uses a bounded min-heap as the priority queue, so keeping only the top 5 matches costs about O of n log k. Instead of sorting everything, I will walk through each of these complexities in my narrative to support course outcome 3. These connect to course outcome 3, which is about designing solutions using algorithms and managing trade-offs. I will explain why I chose each algorithm and compare their speed. They also connect to course outcome 4 because these are real techniques used in production applications. Now let me move to category 3, databases. This is the trip model, which defines what a trip looks like in the database. Each trip has these fields: a code to identify it, a name, a length for how long the trip is, a start date, a resort name, a price per person, an image, and a description. Each field has a type and is marked required. But look at line 10. The per person field, which is the price, is set to type string. A string is text, not a number. This means the database cannot do math on it. You cannot calculate average prices. You cannot sort by cheapest to most expensive. It should be number type, not string. This is the user model. It has an email, a name, and the password hash, and salt for security. But notice what is missing. There is no role field. There is no way to tell if a user is an admin or a regular user. Everyone who logs in has the same access level. Here in defensive programming, it says, are imported data and input arguments tested for validity and completeness. Back to the checklist for the database analysis. Under defensive programming, it asks if inputs are tested for validity. Looking at the trips add trip function again, every field on lines 62 through 69 comes straight from what the user sends. There is no validation, no checking if the name is too long, no checking if the price is actually a number, no checking for dangerous characters. If someone sent harmful data, it would go straight into the database. This is called a NoSQL injection vulnerability. Here in the variable section, it says, do all assigned variables have proper type, consistency, or casting? The checklist is also asking about type consistency. As I showed, the price field is stored as text instead of a number. This creates problems anytime you try to do calculations or comparisons with it. And looking at all the database queries in this controller, they only use the most basic operations. Find everything, find one, create, update, delete. There are no advanced features like aggregation for statistics, no text search indexes for searching trip content, and no optimized indexes for faster lookups on multiple fields. So here are my planned enhancements for databases. First, I will add aggregation pipelines. This let the database calculate things like the average price of trips to each destination or how many trips go to each resort, all inside the database without loading the data into the app. Second, I will fix the trip model. I will change the price field from string to number and add proper validation rules, like making sure the name is not too long and the price is a positive number. I will also add automatic input cleaning, so dangerous data gets stripped out before it reaches the database. Third, I will add text search indexes. This lets the database efficiently search through trip names and descriptions for keywords, instead of loading all trips and searching in the app code. Fourth, I will add roles to the user model. Admins will be able to create, edit, and delete trips, but regular users will only be able to view them. This is called role-based access control. Fifth, I will add input sanitization to prevent NoSQL injection attacks on all database queries. To be concrete about how that sanitization works, a NoSQL injection happens when a user sneaks a MongoDB operator, like a key that starts with a $sign, into the request body, so it changes what the query does. My sanitization layer will strip out any operator keys. meaning anything beginning with a $sign or containing a dot from rec.body before it ever reaches a Mongoose query, so user input can only be treated as data and never as a query operator. Combined with the schema validation and the type fix on the price field, that is what logs in course outcome 5, the security mindset. All of these connect to course outcome 5, which is about having a security mindset, preventing injection attacks, validating all input, and controlling who can do what are all security improvements. They also connect to course outcome 3, because choosing the right database indexes and aggregation strategies involves making trade-offs between speed and storage. To wrap up, I reviewed the Travlr application across all 3 categories. In software design, I found a security issue with the CORS allowing any website to call the API, a missing login check on the delete route, bugs in the error handling where undefined variables would crash the server, and a lack of documentation. I plan to fix this by rebuilding the front end in React with TypeScript and refactoring the back end with proper error handling. In algorithms, I found that the app has no search, no sorting, no filtering, and no pagination. Everything is loaded at once with no processing. I plan to add efficient sorting, search with ranking, page-by-page loading, and a recommendation feature. In databases, I found that the price is stored as text instead of a number. There is no input validation to prevent attacks. There are no roles to control who can do what, and the database queries use only basic operations with no advanced features. I plan to add aggregation pipelines, proper validation, text search indexes, and role-based access control, and input sanitization. Together, these enhancements cover all the 5 course outcomes: collaborative environments through better documentation and this code review, professional communication throughout this video and my written narratives, algorithms through the search and recommendation features, modern tools through the React migration and testing, and security through input validation, access control, and injection prevention. Thank you for watching.